Hello there, and welcome back to the Sleep Science. Tonight, you stand on a shoreline that no longer exists. The tide slides in under a violet sky, foam whispering across sand that will, in a few million years, be stone. Behind you, a skyline glows, glass towers catching the last light, highways humming, satellites blinking patiently overhead. It all feels permanent, solid, unshakable. And yet, in the language of geology, it is thinner than mist. If Earth has hosted 4.5 billion years of experiments, you and everyone you know occupy only the last flicker before midnight. And here's the uncomfortable little lullaby. If there was a civilization before us, you probably wouldn't survive long enough to find its ruins. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And as you settle in, tell me where you're listening from and what your local time is. There's something comforting about knowing that while you're drifting off in one corner of the world, someone else is wide awake under a completely different sky. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You imagine Earth's timeline as a long hallway stretching behind you. The walls are layered in rock, banded reds, chalky whites, glittering seams of quartz. Each layer marks a chapter. The Cambrian explosion. The reign of dinosaurs. The slow shuffle of continents. And then, at the very end, like a sticky note slapped on a cathedral wall, there's you. Humans have existed for roughly 300,000 years. Industrial civilization. Barely 200. If Earth's history were compressed into a single calendar year, modern industry would appear in the last few seconds before midnight on December 31st. That's not poetic exaggeration. That's a mainstream geological comparison scientists often use to convey deep time. You are living in the geological equivalent of a sneeze. And yet you tend to assume you're first. First to build cities. First to burn fuel on purpose. First to change the atmosphere. First to look up and ask, is this all there is? But what if you're not? The thought creeps in softly. Not in a dramatic, ancient aliens on cable TV way. Just a quiet scientific curiosity. Earth is old, astonishingly old. Complex life has existed for over 500 million years. Dinosaurs roamed for about 165 million years, far longer than mammals have been dominant. Anatomically, modern humans are late arrivals to a party that started unimaginably long ago. Historians still argue whether intelligence like yours is an inevitable outcome of evolution or a rare cosmic fluke. That debate alone leaves space for a tantalizing possibility. If intelligence can arise once, could it have arisen before? You stroll deeper into the hallway of time. Most of human history left almost nothing behind. The earliest cities, Uruk, around 4000 BCE, were built of mud brick. Mud brick melts back into mud. Even stone monuments erode. The Great Pyramid of Giza, constructed around 2560 BCE, has already lost its smooth outer casing. Given enough rain, wind, tectonic movement, and patience, even pyramids become anonymous hills. Now stretch that erosion across tens of millions of years. Mountains rise and crumble. Continents collide and split apart. Ocean floors are swallowed into the mantle through subduction. The surface of Earth is not a museum. It's a recycling machine. There's a quirky little geological tidbit that often surprises people. The oldest intact oceanic crust on Earth is only about 200 million years old. That's it. Anything older has been dragged down into the mantle and remelted. So if a coastal civilization had thrived 300 million years ago, its seabed cities would be gone. Literally melted back into magma. Comforting, right? Sleep well. You pause and look at your own world. Steel skyscrapers. Fiber optic cables. Microchips etched with nanometer precision. It feels indestructible. But steel rusts. Concrete fractures. Plastics fragment into microscopic grains. Even the proudest monument becomes sediment under enough pressure and time. There's a reason paleontologists find bones more often than buildings. Biology has a knack for fossilizing in ways architecture does not. Here's the gentle irony. Trilobites, those humble little marine arthropods, left more durable evidence of their existence than your entire smartphone supply chain ever will. Somewhere in a future rock layer, a trilobite shell might sit beside a faint smear of what was once your civilization. A chemical anomaly, perhaps, but no shining tower. And that's where the question sharpens. If an industrial civilization had risen, say, 100 million years ago, long before humans, what would you expect to find? Not marble statues. Not intact libraries. Those would vanish in a geological heartbeat. Instead, you might search for subtler fingerprints, strange isotopic ratios, abrupt climate shifts, layers enriched with synthetic compounds. You feel the scale pressing gently against your thoughts. For most of Earth's history, life was microbial. For billions of years, single-celled organisms ruled the seas. Complex animals only appear relatively late. So the window for a technologically capable species is narrower than the planet's age suggests, but it is not non-existent. Dinosaurs, after all, had a long reign. Mammals quietly diversified in their shadow. Evolution experiments constantly. There's even a fringe but intriguing speculation that intelligence might not always look like primates with opposable thumbs. Some paleontologists have mused, mostly playfully, about what a dinosaur-descended intelligence might have resembled if the asteroid 66 million years ago hadn't intervened. Would it have worn little lab coats? Probably not. But evolution doesn't have a rulebook that says, only apes apply. And yet, you must tread carefully. The absence of obvious ruins is not proof of a hidden empire. Extraordinary claims demand extraordinary evidence. The scientific method insists on patience. Still, the vastness lingers. When you walk across a rocky outcrop, you are stepping on compressed time. Every grain beneath your shoe may have once been seabed, desert dune, volcanic ash. You are not at the end of Earth's story, just a sentence near the back cover. If there was another chapter before yours, it may not read like science fiction. It might be written in chemistry, in carbon ratios, in a sudden unexplained warming spike buried deep in ancient sediment. And tonight, as the imaginary tide rolls in around your ankles, you begin to sense how easy it would be to miss it. A civilization could rise, flourish, alter its world, and vanish, leaving behind only a thin, puzzling line in stone. The hallway of time stretches farther back than your mind comfortably travels. And somewhere in that dim corridor, there may, or may not, be footprints that look almost like your own. You take one last glance at the glowing skyline behind you. It feels eternal. Geology smiles softly and says, "We'll see." The skyline behind you flickers, not because the power grid fails, but because you begin to stretch your imagination forward. You let the centuries roll. The hum of traffic fades. Windows shatter under windstorms no one repairs. Ivy crawls patiently up concrete like it has all the time in the world, because it does. You stand in your own future ruins. It doesn't even take an asteroid. That's the humbling part. No dramatic fireball streaking across the sky, no dinosaur-ending catastrophe. Just time, neglect, and chemistry doing what they've always done. Steel beams oxidize into reddish powder. Reinforced concrete cracks as water seeps in, freezes, expands. Glass towers collapse into glittering drifts. Within a few hundred years of abandonment, most modern cities would look less like Blade Runner and more like a slightly overgrown parking lot. There's a mainstream historical example that always startles people. The ancient city of Angkor in Cambodia, once home to perhaps 1 million people in the 12th century, was largely reclaimed by jungle within centuries of decline. Stone temples survived, yes, but wooden homes, markets, everyday life? Gone. Swallowed by roots and humidity. If that can happen in under 1,000 years, imagine 10,000. Or 1,000,000. You keep fast-forwarding. 10,000 years from now, without maintenance, dams crumble. Roads fracture and sink. The Hoover Dam, that towering concrete wall completed in 1936, would not stand indefinitely. Concrete slowly weathers, freeze-thaw cycles gnaw at it. Given enough time, even the proudest engineering marvel becomes a strangely straight cliff. Historians still argue whether our digital age will leave any meaningful archaeological trace at all. Hard drives demagnetize. Servers corrode. Cloud storage, despite sounding celestial, is really just someone else's computer in a warehouse. And warehouses burn. It's almost funny. You back up your photos 3 times, and geology casually presses delete. Now you push further. Hundreds of thousands of years. Ice ages return. They have before. During the last glacial maximum, around 20,000 years ago, massive ice sheets covered much of North America and Europe. A mile of ice is not gentle. It grinds mountains down. It scrapes landscapes clean like a cosmic sanding block. Entire cities under such a sheet would be crushed, smeared, and redeposited as a faintly unusual sediment layer. You picture Manhattan under a kilometer of ice. Skyscrapers flattened. Subway tunnels compressed. Everything churned into a geological smoothie. It's not dramatic. It's methodical. The planet doesn't rage, it just persists. And here's a quirky detail. Archaeologists have found Roman concrete structures, like parts of the Pantheon built around 125 CE, that have survived nearly 2,000 years, partly because Roman concrete used volcanic ash that actually strengthens over time when exposed to seawater. Meanwhile, some modern concrete deteriorates faster. So the Romans may outlast us in certain respects, which is both impressive and slightly embarrassing. But 2,000 years is nothing in deep time. You let millions of years flow past. Continents shift. Africa inches toward Europe. California slides north along the San Andreas Fault. The Atlantic widens by a few centimeters each year. Your fingernails grow faster. It sounds trivial until you multiply it by 10 million. Coastlines redraw themselves entirely. Ocean levels rise and fall dramatically over geological cycles. During the last ice age, sea levels were about 120 meters lower than today. Vast stretches of continental shelf were dry land, prime real estate for early human settlements. When the ice melted, those areas drowned. If an advanced civilization had flourished along ancient coastlines millions of years ago, rising seas would have hidden its foundations beneath sediment. Out of sight. Out of mind. There's an eerie precedent. The ancient city of Heracleion in Egypt, once a bustling port, sank into the Mediterranean over 1,000 years ago and was only rediscovered in 2000. And that was recent history. Divers could still recognize statues and inscriptions. But give that city another million years. Add tectonic pressure. Add sediment buildup. Recognition fades into ambiguity. You begin to understand the scale of the problem. If your own civilization vanished tomorrow, clear evidence of its complexity might persist for a few thousand years in favorable conditions. Maybe tens of thousands. But after millions, the obvious markers, buildings, machines, roads, would be gone. What might remain are indirect signals. A strange spike in carbon dioxide locked into rock. An unusual concentration of heavy metals. A thin band rich in synthetic polymers, if any survive chemical breakdown. And even those would blur. Geological processes remix sediments. Rivers erode old layers and redeposit them elsewhere. Subduction zones swallow crust. It's not just that ruins decay. The very ground beneath them moves, melts, and reforms. You walk through the imaginary remains of your future. A toppled radio tower lies half buried in sand. Its metal skeleton is brittle, flaking away. You try to imagine a paleontologist 50 million years from now examining this layer. Would they even know it was a tower? Or would it just look like an odd cluster of iron-rich minerals? There's a soft, humbling humor in it. You worry about preserving your phone from scratches, and Earth is planning to run it through tectonic laundry. But here's the crucial turn. If your civilization is this fragile, why assume any prior one would have left obvious ruins? That's the trap. When people imagine a lost civilization, they picture stone temples hidden in jungles, waiting to be discovered. But if that civilization predates humans by tens of millions of years, there would be no jungle temple. Only rock layers. Chemical whispers. Historians still argue whether we overestimate the permanence of monumental architecture because we're biased by what has survived from relatively recent history. You see pyramids and assume endurance. But the pyramids are barely middle-aged in geological terms. The Earth is not kind to surface features. It is patient, persistent, and deeply uninterested in preserving your monuments for nostalgia. As the centuries cascade in your mind, you feel your sense of permanence dissolve. The world you know is less like a carved statue and more like a sandcastle between tides. Impressive. Intricate. But temporary. And if that is true for you, armed with satellites and nuclear reactors and a global internet, then any civilization that rose before you would have faced the same quiet erasure. No dramatic vanishing required. Just time. You kneel now, not in a ruined city, but beside a slab of stone. It's cool under your fingertips, faintly gritty, layered like a mille-feuille pastry baked by pressure and patience. You brush away imaginary dust and ask a simple question: what actually survives? Not what you hope survives. Not what looks impressive on a postcard. What endures when millions of years pass and the planet keeps rearranging the furniture? Fossilization, you realize, is rare. Incredibly rare. Most living things never fossilize at all. When a creature dies, it's usually eaten, scattered, decomposed by microbes, or dissolved. To become a fossil, an organism typically needs rapid burial. Mud, sand, volcanic ash, something that shields it from oxygen and scavengers. Hard parts help. Bones, shells, teeth. Soft tissues? Almost always gone. This is a mainstream paleontological fact. The fossil record is biased toward organisms with durable structures and those that lived in environments conducive to burial, like river deltas or shallow seas. That's why you have entire museums filled with marine shells and dinosaur femurs, but very few fossilized jellyfish birthday parties. Now shift that understanding toward cities. Your skyscraper is mostly steel and glass. Your smartphone is a delicate sandwich of rare earth metals, silicon wafers, polymers, and hope. None of that fossilizes in the traditional sense. Steel oxidizes. Aluminum corrodes. Plastics break down under ultraviolet light and mechanical stress, fragmenting into smaller and smaller pieces. Given enough time and tectonic heat, even those fragments chemically alter. You picture a future geologist splitting open a rock from 2024. They might not find a recognizable phone. They might find a thin layer unusually rich in certain metals, copper, nickel, chromium, far more concentrated than typical background levels. It would look less like an object and more like a geochemical eyebrow raise. There's a quirky tidbit paleontologists like to mention. Chicken bones may be one of the most enduring markers of your era. Domestic chickens number in the tens of billions and are distributed worldwide. Their bones are distinctive, abundant, and often buried in landfills where rapid sedimentation can occur. If any vertebrate fossil screams industrial age, it might be the humble chicken nugget's ancestor. Not exactly the legacy you imagined, but here you are. Meanwhile, entire mountain ranges have vanished from the record. The Appalachian Mountains were once as tall as the Himalayas. Over hundreds of millions of years, erosion shaved them down to rolling hills. If mountains struggle to keep their sharpness, what chance does a shopping mall have? Historians still argue whether gaps in the fossil record represent true absences of life or merely the brutal selectivity of preservation. That debate matters here. Absence of evidence is not always evidence of absence, but it is often evidence of terrible odds. You run your hand along the rock layer again. Fossils are not photographs. They are interpretations. A trilobite shell preserved in shale tells you an organism lived there. But it doesn't tell you about its thoughts, its behaviors beyond certain traces, its social structures. Now imagine trying to reconstruct an entire technological society from a thin anomaly in carbon isotopes. It's like trying to deduce the existence of the internet from a slightly odd bump in atmospheric chemistry. Good luck. Consider concrete. Modern concrete is mostly limestone-derived cement mixed with sand and aggregate. Over time, it fractures. In certain conditions, buried concrete could lithify and resemble natural rock. Without context, it might not scream, sidewalk. It might just look like oddly uniform sediment. Glass, too, returns to sand in slow motion. Under high heat and pressure, it can melt and recrystallize. Microchips, those marvels of nanotechnology, are wafer-thin and fragile. Subduct them into the mantle and they become indistinguishable from the minerals around them. Your cutting-edge processor becomes geological oatmeal. And yet, there are hints that some materials could linger. Certain synthetic compounds, like specific plastics, are chemically novel. They don't have natural analogues in pre-industrial sediments. If buried quickly and shielded from UV radiation, fragments might persist as technofossils. Scientists already use this term to describe human-made objects preserved in geological contexts. Imagine a future species finding a compressed layer rich in microplastics. They wouldn't see grocery bags. They'd see a strange concentration of long-chain polymers embedded in rock. Would they interpret that as biology? Industry? Some bizarre natural resin bloom? It depends on their framework. You lean back and glance at the fossil record's grand timeline. The Cambrian explosion, around 541 million years ago, shows a rapid diversification of life in marine sediments. Before that, the record is sparse, dominated by microbial mats and simple organisms. For billions of years, Earth hosted life that left little dramatic architecture behind. Stromatolites, layered structures built by cyanobacteria, are among the few clear remnants of deep ancient ecosystems. They look like lumpy rocks. Because they are. If a civilization existed before complex land animals, its traces would be even harder to distinguish from microbial or chemical signatures. And here's a slightly unsettling thought. Even today, you have trouble distinguishing certain natural geological formations from artificial ones without context. There have been cases where naturally fractured rocks were initially mistaken for tools, and vice versa. Pattern recognition is tricky. You see faces in clouds, you might see cities in strata. So you begin to appreciate the central problem. If an industrial civilization rose 50 million years ago, built cities along coastlines, mined metals, burned fuels, and then vanished, what would remain? Not monuments. Not highways. Probably not even clear artifacts. Instead, there would be subtle anomalies layered into sedimentary rock, unusual ratios of carbon isotopes from fossil fuel combustion, elevated heavy metals, maybe a thin layer of synthetic compounds. But even those signals could blur over tens of millions of years. Erosion mixes layers. Chemical processes diffuse boundaries. Tectonics recycles crust. The signal-to-noise ratio drops. You chuckle softly at the irony. Humanity spends billions preserving digital archives in climate-controlled vaults, while a trilobite needed only to fall into the right patch of mud. The stone beneath your hand feels patient. It has seen oceans come and go. Forests rise and collapse. Species dominate and vanish. If there were others before you, clever, tool-making, atmosphere-altering others, their grand libraries would not greet you with dusty shelves. Their memory would be compressed into chemistry. And unless you know exactly where and how to look, you might walk right over it, mistaking a whisper for silence. You shift from kneeling at the rock face to standing in a quiet university office, the air faintly scented with old books and dry erase markers. On the desk lies a deceptively simple question. If an industrial civilization existed millions of years before humans, would you even be able to detect it? This isn't late-night radio speculation. In 2018, two scientists, astrophysicist Adam Frank and climate scientist Gavin Schmidt, published a peer-reviewed paper outlining what they called the Silurian Hypothesis. The name is playful, borrowed from a fictional intelligent reptile species in Doctor Who, but the question is serious. Could a prior industrial civilization have existed in Earth's deep past without leaving obvious fossils of cities and machines? You lean closer. The hypothesis doesn't claim such a civilization did exist. It simply asks how you would know. It's a thought experiment, a way to examine the durability of industrial signatures in the geological record. And that's where your earlier musings about fragile skyscrapers and fossil biases come rushing back. The scientists point out a mainstream reality. Industrial civilization leaves global-scale signals. You are currently altering the carbon cycle by burning fossil fuels, releasing carbon that was locked underground for hundreds of millions of years. This changes the ratio of carbon isotopes, specifically carbon-12 and carbon-13, in the atmosphere and oceans. That shift is measurable in sediments and ice cores. If you vanish tomorrow, that isotopic fingerprint would linger in rock layers for millions of years. Not your buildings. Not your Wi-Fi password. But your carbon signature. Yes. Historians still argue whether similar abrupt carbon isotope excursions in ancient geological periods are entirely natural or whether some remain poorly understood. Most are confidently explained by volcanic activity, methane releases, or other climate processes. But the Silurian hypothesis invites you to ask, could an industrial civilization produce a similar anomaly? You picture the Paleocene-Eocene thermal maximum, about 56 million years ago. During this event, global temperatures spiked dramatically, by about 5 to 8 degrees Celsius. There was a significant negative carbon isotope excursion, indicating a rapid release of carbon into the atmosphere. Oceans acidified. Ecosystems shifted. Mainstream science attributes this to massive natural carbon releases, perhaps volcanic activity associated with the North Atlantic igneous province, or destabilized methane hydrates. These are powerful, evidence-backed explanations. But here's the intriguing twist. The pattern, a rapid injection of carbon followed by warming and ocean acidification, resembles what you are doing now. On a smaller timescale, yes. But structurally similar. The Silurian hypothesis asks you to consider, if a prior civilization had burned large quantities of fossil fuels, would its signature look distinguishable from natural carbon release events? You feel the subtlety of the problem. Nature is already capable of dramatic climate swings. Flood basalts can erupt for hundreds of thousands of years. Methane clathrates can destabilize. The planet doesn't need factories to heat up. So how would you tell the difference? One suggestion involves synthetic compounds, plastics, persistent organic pollutants, certain isotopes produced by nuclear reactions. These are less likely to have natural analogs. For example, the detonation of nuclear weapons leaves behind specific radioactive isotopes like plutonium-244 with distinctive half-lives. If you found a thin, global sediment layer enriched with such isotopes dating back tens of millions of years, eyebrows would not just raise, they would achieve orbit. But here's the catch. Many radioactive isotopes decay completely over geological timescales. After tens of millions of years, most short-lived isotopes would be gone. Only longer-lived ones might persist, and even then, diluted and redistributed. It's like trying to prove someone lit a match in a hurricane, after the hurricane has been running for 1,000,000 years. There's a quirky detail in the paper that feels almost poetic. The authors note that even your current plastic production, enormous as it seems, would form only a thin layer in the sedimentary record. Detectable, perhaps, but thin. Your Anthropocene might be visible as a geological boundary, sharp, chemically distinct, but not architecturally obvious. You smile faintly at the humility of it. All your megacities compressed into a line thinner than a fingernail. And yet, that line would matter. Geologists already debate whether the Anthropocene should be formally recognized as a new geological epoch. The argument centers on clear, global markers, radioactive fallout from mid-20th century nuclear tests, plastic pollution, dramatic shifts in carbon and nitrogen cycles. Historians still argue whether future geologists will define your era primarily by climate change, biodiversity loss, or nuclear signatures. It's oddly comforting that even your planetary-scale disruptions must pass a committee vote. So if a Silurian-like civilization existed 100 million years ago, you wouldn't expect to find its laptops fossilized in amber. You'd look for abrupt geochemical anomalies, rapid carbon shifts, unusual metal concentrations, synthetic-like compounds without natural explanation. But, and this is crucial, many ancient anomalies already have well-supported natural explanations. Science does not require a lost civilization to account for them. Volcanoes, tectonics, orbital cycles, these are more than capable of reshaping climate. The Silurian hypothesis doesn't smuggle in aliens or secret reptilian overlords. It sharpens your tools. It forces you to ask how unique your industrial footprint really is. If it turns out your atmospheric scars are easily mimicked by natural processes, that's humbling. If they are uniquely sharp and unprecedented, that's also humbling. You begin to sense the deeper purpose of the thought experiment. It's not about proving you're second. It's about understanding how visible you are. If you vanished and intelligent life evolved again 50 million years from now, would they detect you? Would they debate you in quiet offices, wondering if the strange carbon spike in the early Cenozoic was caused by volcanoes, or by something that built cities and worried about Wi-Fi signal strength? You glance back at the imaginary rock layer. Somewhere within it, perhaps, lies the faintest possibility of a prior industrial whisper. Or perhaps not. Either way, the question has changed you. You are no longer asking, where are the ruins? You are asking, what would a civilization look like after the planet has had millions of years to forget it? And that is a much more interesting mystery. You move from the quiet office back into the field, this time standing on a wind-scoured outcrop where ancient seabed has been tilted toward the sky. The rock is striped in subtle shades of gray and rust, each band a former year, a former century, a former age. You run your fingers across it like you're flipping through the pages of a planetary diary. If a prior civilization altered the climate, this is where you would look. Not for statues. For chemistry. Modern climate science leans heavily on ice cores and sediment cores, long cylinders drilled from glaciers or ocean floors that preserve atmospheric and environmental conditions in layered form. In Antarctica and Greenland, ice cores stretch back hundreds of thousands of years. Tiny bubbles trapped in the ice hold ancient air, allowing scientists to measure past concentrations of carbon dioxide and methane directly. That's not speculative, it's one of the most powerful tools in paleoclimatology. You can literally sample the breath of the past. But ice only survives so long. Beyond about 800,000 years, you rely more on ocean sediments and rock formations. In those, you don't get air bubbles, you get proxies. Ratios of oxygen isotopes in tiny fossil shells reveal past ocean temperatures. Carbon isotope ratios hint at shifts in the global carbon cycle. Layers rich in certain minerals suggest volcanic episodes. You imagine lowering a drill into the seafloor, extracting a core that spans millions of years. It's surprisingly unimpressive to look at, just a long, muddy cylinder. But inside, it holds a timeline far older than any civilization you know. Here's a mainstream historical anchor, the discovery of the Paleocene-Eocene thermal maximum. That dramatic warming event 56 million years ago came largely from analyzing such sediment cores. Scientists observed a sharp negative carbon isotope excursion, evidence that a large amount of carbon-12 flooded the system. Temperatures spiked. Ocean chemistry shifted. Species migrated or went extinct. It was abrupt in geological terms, though still unfolding over thousands of years. You tilt your head. If an industrial civilization had existed before humans and burned vast quantities of fossil fuels, you might expect something similar. A sudden carbon isotope shift, global warming, ocean acidification. But here's the tricky part. Earth has done this sort of thing without factories. Massive volcanic provinces, like the Siberian traps around 252 million years ago, released enormous amounts of carbon dioxide. That event is linked to the Permian Triassic extinction, the most severe mass extinction in Earth's history. No smokestacks required. Historians still argue whether certain ancient warming events were driven primarily by volcanic CO2, methane clathrate release, orbital variations, or complex feedback loops between them. The debates can get wonderfully technical, and occasionally heated, which feels ironic for climate discussions. You crouch beside the imagined sediment core and think about resolution. The finer the layers, the more precisely you can pinpoint changes. But as you go further back in time, layers compress, mix, and blur. A rapid event might smear across thousands of years in the record. If a civilization lasted only a few thousand years, an eye blink in deep time, its chemical signal could blend into the background noise of natural variability. There's also the matter of scale. Your industrial civilization has dramatically altered atmospheric CO2 in just 2 centuries. That speed is unusual compared to many natural events. Some scientists argue that the rate of change you're causing may be one of the clearest distinguishing features of the Anthropocene. But would that rapid spike remain crisp after 50 million years of sedimentation, tectonic compression, and chemical diffusion? Or would it look like just another squiggle in the long climate graph? You picture a future geologist frowning at a graph, muttering, that's odd, before turning the page and attributing it to some newly discovered volcanic pulse. It's humbling to think your entire global drama could be summarized as a minor anomaly footnote. And yet, anomalies matter. There are periods in Earth's past where climate shifts seem unusually abrupt or severe. The end Permian extinction, for instance, wiped out an estimated 90% of marine species. The mainstream explanation involves massive volcanism, greenhouse warming, ocean anoxia. But the scale of devastation is still staggering. Fringe thinkers sometimes leap from such events to imaginative conclusions: lost high-tech reptilian empires, ancient nuclear wars among dinosaurs. It makes for entertaining documentaries at 2 a.m., but extraordinary claims require extraordinary evidence, and none has surfaced. No unmistakable alloy beams in Triassic rock. No fossilized laptops nestled beside ammonites. Still, you allow the quieter question to linger. Could a modest industrial civilization, far smaller than yours, have nudged the climate in ways that are now indistinguishable from natural processes? You imagine them, not necessarily humanoid, not necessarily dramatic. Perhaps a coastal species that discovered combustion, mined surface metals, altered landscapes for a few thousand years before succumbing to climate feedbacks or asteroid impact or their own overreach. Their atmospheric mark might be real, but subtle. There's a quirky geological phenomenon called a hyperthermal, short-lived intervals of extreme warmth in the geologic record. Some last tens of thousands of years. They leave chemical signatures but no obvious physical monuments. You could stare at the rock face and never suspect anything beyond natural variability. You feel the breeze across the outcrop, the faint smell of dust and salt. The Earth's diary is thick, but it's written in a language of isotopes and minerals, not headlines. If there was a previous civilization, you wouldn't expect a chapter titled, "The Age of Lizard Engineers." You'd expect a faint, puzzling paragraph, a chemical hiccup in an otherwise natural narrative. And that's what makes this both frustrating and beautiful. The evidence, if it exists, would be subtle, debatable, nestled among volcanoes and orbital cycles. You trace one last band in the rock. It looks ordinary. It probably is. But somewhere in these layers, whether from nature alone or something more curious, the climate has spiked, cooled, surged, and steadied again, over and over. And you, with all your satellites and supercomputers, are just the latest ripple in that long, patient story. You leave the windswept outcrop and step into a landfill. Not the romantic part of tonight's journey, perhaps, but oddly appropriate. The air is warm, faintly sour, layered with the scent of decomposing leftovers and last year's trends. Seagulls wheel overhead like impatient critics. Beneath your feet lies a compressed anthology of your civilization. Plastic bottles, circuit boards, aluminum cans, fragments of everything you thought you needed. If you want to know what might survive you, this is the place to look. Plastic is one of your strangest inventions. Unlike wood or bone, it doesn't have a neat biological recycling pathway. Many common plastics, polyethylene, polypropylene, are long chains of carbon atoms arranged in ways that rarely occur in nature. They can photodegrade under ultraviolet light, breaking into smaller fragments, but they don't simply vanish. They become microplastics. Then, nanoplastics. Tiny, persistent confetti drifting through soil and sea. This is a mainstream environmental fact. Microplastics have been found in ocean trenches, Arctic ice, even human bloodstreams. You have effectively dusted the planet in polymer glitter. Congratulations! Now imagine those particles settling into sediment layers, buried by silt, compacted over millions of years. Some may chemically alter under heat and pressure. Some may break down completely. But others, especially if shielded from oxygen and UV radiation, could persist as faint polymer residues embedded in rock. Geologists have already coined the term technofossils to describe artifacts of human manufacture preserved in geological contexts. A glass bottle fused with sand into a new mineral-like structure. Concrete conglomerates, sometimes called plastiglomerates, where melted plastic binds with rock and shell fragments into a hybrid material. These are not hypothetical. They exist. You crouch and pick up an imaginary shard of such a plastiglomerate. It looks almost natural, like a pebble with strange colors trapped inside. If found millions of years from now, would it be recognized as artificial? Or interpreted as some peculiar volcanic byproduct? Historians still argue whether future geologists will define your epoch more by radioactive fallout than by plastic. In the mid-20th century, atmospheric nuclear tests released distinctive isotopes, plutonium-239, cesium-137, that spread globally. These isotopes settled into soils and ocean sediments, creating a sharp, datable marker often proposed as the beginning of the Anthropocene around 1950. That radioactive signature is crisp and global. But here's the catch: many isotopes decay. Cesium-137 has a half-life of about 30 years. In a few centuries, it's largely gone. Plutonium-239 lasts longer, 24,000 years, but that's still a blink compared to tens of millions. Over geological timescales, most radioactive fingerprints fade into silence. It's oddly poetic. You split the atom, and the universe politely waits for it to calm down. Still, some traces could endure indirectly. Nuclear reactions can create unusual isotope ratios in certain elements. If a thick, anomalous band rich in specific fission byproducts appeared in ancient rock, scientists would raise questions. But distinguishing that from rare natural nuclear phenomena, like the Oklo Natural Nuclear Reactor in Gabon, which operated about 2 billion years ago due to natural uranium deposits, would require careful analysis. Yes, you heard that right. Earth once ran its own natural nuclear reactor. No lab coats. Just groundwater and uranium-rich rock aligning perfectly. It's a reminder that nature sometimes beats you to your own inventions. So if a prior civilization harnessed nuclear energy millions of years ago, its radioactive waste might not scream, "Intelligent engineers." It might look, to an unsuspecting geologist, like an unusual but natural uranium deposit. Context is everything. You glance around the landfill again. Beyond plastics and radiation, there are metals, aluminum refined from bauxite, rare earth elements concentrated far beyond typical crustal abundance, alloys engineered for strength and lightness. Mining redistributes these elements dramatically. You dig them up from deep ore bodies and scatter them across the surface in cars, wires, and smartphones. Over time, corrosion and erosion would disperse those metals into soils and waterways. Sediments might show unusual spikes in lead, chromium, or nickel concentrations. But here's the complication: volcanic eruptions and hydrothermal vents can also produce metal-rich layers. The Earth is not shy about heavy metals. You begin to see the pattern. Every potential industrial marker has a natural cousin. Carbon spikes, volcanoes, metal anomalies, hydrothermal systems, radiation, natural reactors. It's like trying to identify a single violin in an orchestra where geology plays all the same notes. And yet, combinations matter. A simultaneous spike in carbon isotopes, synthetic polymer residues, unusual metal distributions, and perhaps nitrogen cycle disruptions, together, would paint a more compelling picture. One anomaly can be dismissed. A cluster becomes intriguing. You brush imaginary dust from your hands. If a civilization predated humans, its technofossils would not look like gleaming robots frozen in stone. They would look like odd chemistry. Subtle, layered, easily misinterpreted. There's a gentle humor in knowing that your era might be immortalized not by art or literature, but by a thin smear of plastic and chicken bones. Somewhere, a future paleontologist might hold up a fossilized femur and declare, "Behold, the dominant megafauna of the early Anthropocene, Gallus domesticus." Not quite the legacy of philosophers and poets, but evolution has a wicked sense of irony. You stand, gazing across the landfill as the wind shifts. Beneath the surface, your civilization is already compressing into tomorrow's strata. If there was another before you, perhaps their landfills once steamed under an alien sun. Perhaps their waste compacted quietly, waiting for curious minds that never came. The Earth does not label its layers. It simply stacks them. And unless you know exactly what signatures to seek, and how to separate them from nature's own experiments, you might never realize that a thin, peculiar band in ancient rock was once someone else's age of industry. You leave the landfill behind and drift toward the shoreline again, but this time the sea does not feel poetic. It feels immense, patient, hungry in the most geological sense. Waves roll in steady rhythm, erasing footprints before you even finish admiring them. If a prior civilization flourished along coasts, as yours has, then the ocean is the first and most efficient eraser. Today, roughly 40% of the human population lives within 100 kilometers of a coastline. That's not an accident. Coasts offer food, trade routes, mild climates. The earliest known cities, like Ur, founded around 3800 BCE in Mesopotamia, thrived near rivers and deltas connected to the sea. Water is convenience. Water is power. But water also moves. During the last ice age, sea levels were about 120 meters lower than today. Vast continental shelves, now submerged, were once dry land. You could have walked from Siberia to Alaska across Beringia. The North Sea basin, now underwater, once held rivers and valleys where humans likely hunted and settled. When the ice melted, those landscapes drowned. Marine archaeologists have already found submerged settlements from more recent prehistory, stone tools and structures off the coasts of India, Greece, and Japan. Nothing rewriting textbooks yet, but enough to prove a simple point: rising seas hide things. Now extend that process not just thousands, but millions of years. Coastlines migrate dramatically over geological time. Continents drift. Basins subside. New ocean crust forms at mid-ocean ridges and is eventually subducted back into the mantle. Remember that unsettling fact: no oceanic crust on Earth is older than about 200 million years. It is constantly recycled. If a civilization thrived along a coastline 300 million years ago, and that coastline sat on oceanic crust, its foundations are gone, literally melted and reincorporated into the mantle. Not buried. Not waiting. Gone. You stare out across the waves and imagine a glittering port city from the Carboniferous period, ships docking beneath towering fern forests. It's an evocative image. Slightly ridiculous, but geologically plausible in the sense that shallow seas covered vast areas during that era. Would anything remain? Perhaps only a faint enrichment of certain minerals in a sediment layer now uplifted into a mountain range. Perhaps nothing at all if the crust beneath it was subducted. Historians still argue whether the earliest human civilizations were more coastal than the archaeological record currently suggests. The bias is obvious. Submerged sites are harder to find. You don't casually stumble upon them while building a parking garage. You need sonar, submersibles, funding, patience. And funding, as you might suspect, is less enthusiastic about "maybe there's something down there" than about "we already found a cool temple." There's also the quiet reality of sedimentation. Rivers constantly deliver silt to the sea. Over time, that sediment can bury coastal structures under meters, then tens of meters, of mud. In oxygen-poor conditions, preservation can be surprisingly good for organic materials. But recognition after millions of years. That's another matter. Picture a stone pier slowly sinking beneath layers of delta sediment. It becomes compressed, lithified, folded by tectonics. 50 million years later, it might emerge as a strangely straight band of rock within a cliff face. Would you recognize it as a pier? Or call it an unusual sedimentary feature? Your mind drifts to a real-world example. The ancient city of Pavlopetri in Greece, submerged for over 5,000 years. Divers can still trace its streets and buildings. But that's a blink in geological time. Give it another few 100,000 years of tectonic movement and sediment compaction, and the clarity fades. There's a quirky oceanographic fact that feels almost unfair. The deep ocean floor is one of the least explored places on Earth. More of the moon's surface has been mapped in detail than some stretches of your own seabed. So when someone says, "We'd have found it by now," you have to smile gently. Found what, exactly? In how much of the 360 million square kilometers of ocean? Still, caution is essential. The vastness of the ocean does not equal hidden skyscrapers. The burden of proof remains high. What the sea truly excels at is transformation. Salt water corrodes metal rapidly. Shipwrecks from just a few centuries ago often degrade into skeletal outlines. Even the RMS Titanic, resting since 1912, is being consumed by rust-eating bacteria. Scientists estimate it may collapse into an unrecognizable heap within decades. Decades. Now multiply that by millions of years. You begin to see the ocean not as a mysterious vault but as a dynamic system, eroding, burying, recycling. It preserves selectively and destroys efficiently. If there was a prior civilization, coastal or maritime, the sea would have been both its lifeline and its undoing. Rising waters during natural warming cycles could have swallowed its cities. Tectonic shifts could have tilted its harbors skyward or dragged them into subduction zones. And yet, some traces might persist in continental shelf sediments, chemical anomalies, unusual debris layers, perhaps even concentrated artifacts in rare, stable basins. The challenge is not only survival of evidence, but discovery. You watch the tide creep closer, foam tracing delicate lines that vanish as quickly as they form. Your own civilization, so enamored with beachfront property, is building again at the water's edge, despite knowing sea levels are rising. It's almost poetic. Or stubborn. Or both. If you are not the first, perhaps those before you also trusted the shoreline a little too much. The sea does not remember who built the docks. It remembers only gravity, temperature, and time. And somewhere beneath its shifting floor, there may, or may not, be the faintest, most ambiguous suggestion that someone once stood where you stand now, listening to waves and believing the horizon would always stay put. You step back from the shoreline and into firelight. Not laboratory fluorescence, not the blue glow of a screen, but flickering orange flames under a dark sky heavy with stars. Around you, voices tell stories. They always have. Long before sediment cores and isotope ratios, humans tried to remember the past with myth. If there was something before you, something lost, would it survive not in stone, but in story? Nearly every culture carries tales of earlier ages, golden eras, or catastrophic resets. In ancient Greek tradition, Hesiod wrote of successive ages of man, gold, silver, bronze, and iron, each declining in virtue and harmony. In Hindu cosmology, time unfolds in vast cycles called yugas, repeating over immense spans. The Maya described previous creations of humanity, each destroyed before the current one endured. And then there are flood myths. The Epic of Gilgamesh, written in Mesopotamia around 2100 BCE, tells of a great deluge sent to wipe out humanity. The Hebrew Bible echoes the story of Noah. Across the world, in China, the Americas, the Pacific Islands, variations appear. Waters rise, civilization falls, a few survive. Mainstream scholars generally interpret these as cultural memories of local flooding events, especially after the last ice age when sea levels rose dramatically. Around 7,600 years ago, for example, the Black Sea may have experienced a sudden influx of Mediterranean water, flooding coastal settlements. Such events can leave deep impressions in collective memory. Historians still argue whether certain widespread flood myths reflect a shared ancestral story or independent responses to common environmental experiences. Water rises in many places. Humans notice. Humans narrate. But as you sit by the fire, you let yourself consider the softer possibility. What if myths are distorted echoes of something much older? Not literal records, but emotional fossils, compressed memories of upheaval passed down until their origins blur. There's a quirky fringe idea that Plato's tale of Atlantis, first described around 360 BCE, was inspired by a real advanced civilization destroyed in antiquity. Most historians view Atlantis as philosophical allegory, a cautionary story about hubris. No credible archaeological evidence supports a sunken superpower in the Atlantic. And yet the story persists. Because it scratches something in you. The suspicion that history might be deeper than textbooks admit. You poke at the fire thoughtfully. Myths are not geology. They cannot date events to millions of years ago. Oral traditions, even when remarkably resilient, stretch back thousands of years at most with traceable continuity. Human language itself hasn't existed in stable form for tens of millions of years. If a civilization thrived before humans, its stories would not survive in your campfire tales. There would be no direct narrative bridge across that abyss of time. Still, you notice a pattern in myth. Cycles. Creation. Flourishing. Catastrophe. Renewal. It mirrors geological reality more than people often realize. Ice ages advance and retreat. Species rise and vanish. Continents assemble and break apart in supercontinents like Pangaea, which formed about 335 million years ago and later split. Your ancestors didn't know about plate tectonics, formally accepted in the mid-20th century. Yet they sensed impermanence. Cities crumble. Rivers shift. Forests burn and regrow. There's even an intriguing anthropological detail. Some Aboriginal Australian oral traditions appear to preserve memories of coastline changes dating back over 7,000 years. That's extraordinary longevity for cultural memory. It shows that stories can anchor environmental shifts across many generations. But 7,000 years is a heartbeat compared to 70 million. You glance up at the stars. Constellations feel timeless, but even they drift slowly over millennia due to stellar motion. If you project far enough back, the night sky of the dinosaurs would look subtly different. If an intelligent species gazed upward 100 million years ago, their constellations would not match yours. Their myths would map a different sky. Historians still argue whether the human tendency to imagine lost golden ages reflects nostalgia for childhood, social commentary, or a deeper psychological need to frame decline and hope. Perhaps you invent Atlantis because you fear your own fragility. There's a gentle humor in that. You worry about being second, yet you can barely keep track of what happened 3,000 years ago without heated debates. Myth is powerful, but it is not a time machine. It cannot carry memory across extinction events and evolutionary turnovers. If there was a pre-human civilization, no storyteller could whisper its name to you now. The lineage of language itself would have been severed. And yet, as the fire crackles, you feel why the idea persists. Story is how you grapple with the unknown. When faced with a puzzling ruin or a dramatic landscape, your mind asks, who was here before? Sometimes the answer is simple, wind and water. Sometimes it's another human culture long gone. And sometimes, the question stretches beyond evidence into wonder. You let the flames die down to embers. The night grows quieter. Myths flicker like the fire, illuminating, imaginative, but limited in reach. If there were others before you, they left no epics carved in accessible stone, no surviving oral traditions carried across species boundaries. Their memory, if real, would not live in poetry. It would live in rock chemistry and fossil layers. Still, you can't help but feel a strange kinship with every ancient storyteller who ever looked at ruins and imagined a forgotten age. Because even now, with satellites overhead and sediment cores in laboratories, you are doing the same thing, just with better tools and slightly less dramatic background music. The question lingers in the cooling air, not whether myths prove anything, but whether your own civilization will one day become a myth to whoever, or whatever, comes next. The firelight fades, and in its place rises stone. Immense, geometric, unapologetically heavy stone. You find yourself standing before a pyramid, its edges cutting into the sky with stubborn precision. Monumental architecture has a way of making you feel small and slightly underdressed. If there were civilizations before yours, advanced, organized, capable, wouldn't they have left something like this? Something unmistakable? The Great Pyramid of Giza, built around 2560 BCE during Egypt's 4th dynasty, remains one of the most iconic structures on Earth. It was originally about 146 meters tall and constructed from an estimated 2.3 million stone blocks. For thousands of years, it stood as the tallest human-made structure on the planet. That's not fringe speculation. That's well-established archaeology. And yet, despite its grandeur, even the pyramid has eroded. Its smooth limestone casing stones are mostly gone, stripped away in later centuries. What remains is a rougher core, weathered by wind and time. Give it another few million years, and even this monument will slump into anonymity. You walk along its base, running your hand over the warm stone. The precision is impressive, but not impossible. Archaeologists have found worker villages, tools, quarry sites. The pyramid is extraordinary, yes, but firmly within the capabilities of ancient human engineering. Still, historians still argue whether certain construction techniques were more sophisticated than we fully understand, especially regarding labor organization and ramp systems. Debate is healthy. Mystery sells documentaries. But no credible evidence suggests extraterrestrials or forgotten supercivilizations built Giza. Humans did. Sweaty, organized, clever humans. So why do so many people feel compelled to attribute ancient monuments to lost advanced cultures? Part of it is underestimation. You tend to assume that technological progress is linear, that earlier equals primitive. When confronted with massive stone structures built thousands of years ago, it can feel easier to imagine hidden knowledge than to accept that ancient societies were capable, disciplined, and innovative. There's also the allure of the unexplained. Take Puma Punku in Bolivia, with its precisely cut stone blocks. Or the polygonal masonry of Sacsayhuaman in Peru, where stones fit together so tightly you can't slide a knife blade between them. These are real sights, genuinely impressive. But impressive does not equal impossible. Quirky tidbit: experiments have shown that with simple tools, patience, and clever use of abrasion techniques, ancient-style stone cutting can achieve remarkable precision. It's less about laser beams and more about time, and a workforce not distracted by smartphones. You circle the pyramid in your mind and widen the lens. Megalithic structures exist across the globe. Stonehenge in England, built around 3000 to 2000 BCE. The Moai statues of Easter Island, carved between 1250 and 1500 CE. The massive earthen mounds of Cahokia in North America, thriving around 1050 CE. These sites demonstrate that large-scale construction arises independently in many human societies. Monumentality seems to be a recurring feature of organized civilization. Now ask yourself, if a civilization existed millions of years before humans, would you expect similar monuments to survive? Probably not. Stone weathers. Tectonics shift. Erosion smooths edges. A pyramid left exposed for 50 million years would not look like a pyramid. It would look like a hill with suspiciously straight bedding planes, if you were lucky. More likely, it would be dismantled entirely by geological processes. And here's the deeper point. Even today, distinguishing natural from artificial structures is not always straightforward. There are rock formations that look eerily sculpted. Columns, arches, hexagonal basalt formations like the Giant's Causeway in Northern Ireland. These were formed by cooling lava, not architects. Pattern recognition is a blessing and a curse. You see design where there is none. Faces in cliffs. Walls in stratified rock. Entire internet forums dedicated to zooming in on Mars photos and declaring ruins. Historians still argue whether certain controversial sites, like the Yonaguni Monument off Japan, are entirely natural formations or partially human-modified. The majority view leans toward natural geology, possibly shaped slightly by human hands. The debate persists because the line between natural geometry and human intention can blur. You pause and consider scale again. Human civilization has built in stone for maybe 5,000 years. That's generous. Before that, most structures were wood, mud brick, plant fiber, materials that vanish quickly. If a pre-human civilization favored different materials, biopolymers, composites, even metals, their monumental architecture might not resemble stone pyramids at all. It might leave no obvious silhouette. You picture a grand metropolis built primarily of advanced alloys and lightweight materials. Over millions of years, corrosion and tectonic stress would reduce it to scattered mineral concentrations. No iconic skyline fossilized in rock. No convenient tourist attraction for future species. There's a gentle irony in how you equate permanence with stone. Stone feels eternal because it outlasts your lifespan. But even granite yields to time. You step back from the pyramid and let it dissolve into a distant ridge. Monumental architecture proves that complex societies leave marks. But it also proves those marks are temporary on geological scales. If you are searching for evidence of a civilization tens of millions of years older than your own, you cannot expect intact temples. You must think subtler, deeper, more chemically. The absence of ancient megastructures does not conclusively prove you are first. It only confirms that Earth is very good at cleaning up. And as the wind sweeps across the stone, you feel the quiet reminder. Even your proudest monuments are just brief interruptions in a planet that specializes in erasure. The stone fades, and the air turns sharp, colder, drier. You find yourself standing at the edge of a world in flux, about 12,900 years ago. The great ice sheets are retreating, mammoths still roam in shrinking herds, and human hunter-gatherers move across vast open landscapes. Then, quite suddenly in geological terms, the climate snaps back toward near-glacial conditions. This period is known as the Younger Dryas. It's one of the most intriguing climate events in recent Earth history. After the last ice age began loosening its grip, temperatures in the northern hemisphere dropped sharply and stayed cold for roughly 1,200 years before warming again just as abruptly around 11,700 years ago. That final warming marks the beginning of the Holocene, the stable climate window in which all recorded human civilization has flourished. The mainstream explanation involves disruptions to ocean circulation, particularly the Atlantic meridional overturning circulation. As massive glacial lakes drained into the North Atlantic, freshwater influx may have weakened the currents that transport warm water northward. Less heat circulation, more cold. Climate systems are dramatic like that, no villain required. But here is where the mystery thickens. Some researchers have proposed a more explosive trigger, a comet or asteroid impact that ignited widespread fires and contributed to abrupt cooling. This is known as the Younger Dryas impact hypothesis. Proponents point to certain sediment layers containing microspherules, nanodiamonds, and elevated platinum levels at sites across North America and parts of Europe. Critics argue that the evidence is inconsistent, that similar materials can form through terrestrial processes like wildfires or volcanism. The debate has persisted for over a decade, sometimes heated enough to make the climate itself blush. Historians still argue whether the Younger Dryas impact hypothesis represents a genuine paradigm shift or an overinterpretation of ambiguous data. It's a rare case where geology, archaeology, and even public imagination intersect dramatically. Now, here's where the idea of a lost civilization occasionally enters the conversation. Around the end of the Younger Dryas, several megafaunal species, mammoths, saber-toothed cats, giant ground sloths, went extinct in North America. Human cultures, such as the Clovis people, also seem to shift or disappear from the archaeological record around this time. Some fringe theories suggest that an advanced Ice Age civilization existed before this climatic upheaval and was wiped out by catastrophe. It's an alluring narrative, a forgotten society erased in fire and ice, its memory reduced to myth. But here's the sober truth. There is currently no credible archaeological evidence of a technologically advanced global civilization prior to known Holocene societies. No anomalous metal alloys in Pleistocene strata. No fossilized machinery beneath glacial till. Human artifacts from that period are consistent with hunter-gatherer technologies, stone tools, bone implements, hearths. That doesn't make the Younger Dryas uninteresting. Quite the opposite. It underscores how sensitive civilization is to climate stability. The relatively calm climate of the Holocene allowed agriculture to develop independently in multiple regions around 10,000 to 12,000 years ago. Wheat in the Fertile Crescent. Rice in East Asia. Maize in Mesoamerica. Stable seasons mean predictable harvests. Predictable harvests mean surplus. Surplus means cities, specialization, writing, pyramids. You depend on climate consistency more than you like to admit. There's a quirky but telling detail. Ice core data show that at the end of the Younger Dryas, temperatures in Greenland rose by as much as 10 degrees Celsius within a few decades. Decades. That's practically overnight in geological terms. Imagine adapting your agriculture, or your entire way of life, to that. Now imagine, just for a moment, that a civilization slightly more advanced than Ice Age hunter-gatherers had existed. Not skyscrapers and satellites, but organized settlements, perhaps early industry. A sudden climatic whiplash could have destabilized food supplies, migration routes, coastlines. Rising sea levels after the Ice Age ultimately submerged vast low-lying areas where early humans likely lived. Sites like Göbekli Tepe, soon you'll stand among its pillars, date to around 9600 BCE, right after the Younger Dryas ended. Its massive stone enclosures challenge older assumptions that only agricultural societies built monumental structures. Here were hunter-gatherers organizing large-scale construction before widespread farming. It forces you to reconsider what advanced even means. Historians still argue whether complex symbolic culture and large-scale cooperation emerged earlier than once believed, reshaping the timeline of societal development. The Younger Dryas sits right at that threshold. But, and this is essential, the leap from our understanding of early human societies is incomplete to there was a hidden global high-tech civilization is vast. One is evidence-based revision. The other is imaginative extrapolation without supporting data. Still, you can feel why the Younger Dryas captivates people. It's recent enough to overlap with emerging human complexity, yet dramatic enough to feel apocalyptic. A cold snap. Extinctions. Cultural shifts. Rising seas swallowing coastlines where early communities once stood. If you're searching for a reset button in Earth story, this period glows faintly. You stand in that chilly air again, watching ice creep back across tundra. Even small disruptions ripple outward. Societies adapt, or they don't. The Younger Dryas reminds you that civilization is not guaranteed. It depends on stable coastlines, predictable rainfall, manageable temperature swings. Remove those, and even a clever species struggles. So if someone asks, could a pre-Holocene advanced civilization have been erased by a cataclysm 12,900 years ago? The honest answer is this: there is no solid evidence for such a civilization. But there is strong evidence that climate shifts can dramatically reshape human trajectories. The difference matters. You exhale, watching your breath fog in the cold Pleistocene air. Catastrophe does not automatically imply hidden empires. But it does highlight fragility. And that fragility, more than any comet, may be the most important clue in your search for who came before. The cold recedes. The ice thins. You step forward a few centuries past the Younger Dryas and find yourself standing on a dry, wind-swept hill in what is now southeastern Turkey. The horizon rolls gently, grasses whispering in the breeze. At first glance, it looks unremarkable, just another rise in a vast Anatolian landscape. Then you notice the stones. Massive, T-shaped pillars arranged in circles, some towering over 5 meters tall, carved with reliefs of foxes, snakes, birds, and abstract symbols. This is Göbekli Tepe, dated to around 9600 BCE, over 11,000 years ago. Mainstream archaeology agrees on something astonishing. These monumental structures were built by hunter-gatherers before the widespread adoption of agriculture. That alone reshaped long-held assumptions that farming had to come first, that only settled agricultural societies could organize large labor forces for construction. You walk slowly between the pillars. The limestone is weathered but still firm. The carvings are deliberate, confident. Someone planned this. Someone coordinated effort, transported heavy stones, carved intricate imagery. Historians still argue whether Göbekli Tepe represents a ceremonial center that catalyzed agriculture, or whether early cultivation was already quietly underway nearby. The debate continues, reshaping your understanding of how complexity emerges. But here's the key. Nothing at Göbekli Tepe suggests advanced technology beyond what late Stone Age humans could achieve with stone tools, coordination, and time. No metal beams hidden in the soil. No anomalous alloys. No out-of-place microchips beneath the pillars, despite what certain enthusiastic internet threads might imply. And yet, it feels profound. Göbekli Tepe proves that your timeline of primitive to advanced is far messier than you once thought. Monumental architecture did not wait politely for plows. Symbolism did not wait for cities. Humans were socially and cognitively complex long before they domesticated wheat. There's a quirky detail that makes you smile. Some of the animal carvings at Göbekli Tepe appear to depict species that were potentially dangerous: snakes, wild boars, predators. It's possible the site carried ritual or mythic significance tied to the wild world around its builders. Imagine organizing a massive stone project while still worrying about actual wolves outside your camp. Productivity under pressure. Now, consider the broader implication. If your understanding of early human civilization can be appended by a single archaeological discovery buried under a hill for millennia, how confident can you be about what you don't know from far deeper time? The temptation is strong to leap from "we underestimated early humans" to "therefore, we might be underestimating something even older." But discipline matters. Göbekli Tepe sits firmly within the late Pleistocene to early Holocene. Its builders left stone tools, food remains, and other artifacts consistent with known human development. The site expands your timeline of complexity, but it does not shatter it into science fiction. Still, you let your mind stretch. Imagine a similar site not 11,000 years old, but 11 million. The stone pillars, if left exposed, would likely be eroded beyond recognition. Buried deeply enough, they might survive an altered form, but tectonic uplift, folding, and metamorphism could distort them beyond easy interpretation. Historians still argue whether certain deeply buried geological structures, once interpreted as purely natural, might sometimes include subtle traces of biological or even anthropogenic influence. The key word is subtle. Göbekli Tepe teaches you humility. For decades, it sat unnoticed as a simple mound. In fact, it was initially surveyed in the 1960s and dismissed as a medieval cemetery. Only in the 1990s did archaeologist Klaus Schmidt recognize its deeper significance. How many other ordinary hills conceal chapters of your own species' story? Now scale that problem up by millions of years. Erosion, sedimentation, tectonics, all have had far more time to operate. A pre-human civilization's Göbekli Tepe would not sit conveniently under a few meters of soil. It might be compressed into metamorphic rock, folded like pastry layers under continental collisions. Recognition would be exponentially harder. You run your fingers across a carved fox in your imagination. The lines are deliberate, intentional, meaningful. If there were others before you, they too would have left intention carved into matter. The question is whether matter would still remember it. There's also another lesson here, one that feels almost philosophical. Göbekli Tepe suggests that cooperation and symbolic thought precede large-scale technological dominance. Intelligence expresses itself first in meaning, not machinery. So if a prior civilization existed, perhaps its earliest traces would not be industrial scars, but symbolic ones: patterns in rock, deliberate arrangements, alignments with celestial bodies. But again, after tens of millions of years, erosion would blur alignments. Carvings would soften. You glance at the sky above Göbekli Tepe. The same stars shine, though shifted slightly over millennia due to precession and stellar motion. The builders here may have aligned pillars with certain celestial events. Researchers debate this cautiously. Some see astronomical significance, others urge restraint. Historians still argue whether we sometimes project cosmic intentions onto ancient structures because we long for deeper connection. The sky invites interpretation. So does stone. As the wind moves through the pillars, you feel something grounding. You are not the first to revise your understanding of the past. Every generation peels back another layer, reinterprets evidence, adjusts timelines. Göbekli Tepe does not prove a lost supercivilization. But it does prove that the story of complexity is older and more nuanced than once believed. And that, in its own quiet way, keeps the question alive. If you could misjudge your own species' capabilities for thousands of years, what else might you be misjudging? Not because it's fantastical, but because deep time is a patient keeper of secrets. You step back from the pillars. They stand silent, weathered, undeniably human. And yet they whisper the same lesson the rocks have been teaching you all along: certainty erodes. The pillars fade, replaced by something far older. The air grows heavy, thick with the scent of ferns and damp earth. Dragonflies the size of small birds hum lazily over swampy ground. You have traveled back more than 100 million years, into the age of dinosaurs. And now the playful question rises, almost inevitably: could they have built cities? It sounds absurd at first. You picture a Tyrannosaurus attempting delicate masonry with comically tiny arms and have to suppress a sleepy grin. Urban planning was probably not high on its to-do list. But set aside the cartoon image. Dinosaurs ruled the Earth for roughly 165 million years. That is an almost incomprehensible stretch of time. Far longer than mammals, including humans, have dominated terrestrial ecosystems. Modern humans, by contrast, have existed for about 300,000 years. Industrial civilization. 2 centuries. From a purely temporal standpoint, dinosaurs had plenty of opportunity. The mainstream scientific consensus is clear. Non-avian dinosaurs went extinct around 66 million years ago, most likely due to a massive asteroid impact near present-day Chicxulub in Mexico, combined with volcanic activity from the Deccan Traps in India. The fossil record shows no evidence of advanced tool use, metallurgy, or industrial activity among them. But here's where the thought experiment becomes interesting. Intelligence, as you define it, is not unique to humans in a simple, linear way. Certain bird species, modern descendants of theropod dinosaurs, display remarkable cognitive abilities. Crows and ravens use tools, solve multi-step puzzles, and even appear to understand cause and effect. Parrots can learn hundreds of words and apply them contextually. Quirky tidbit: New Caledonian crows manufacture hooked tools from twigs and can bend wires into functional shapes to retrieve food. That's not instinct alone, it's problem-solving. And birds are dinosaurs' closest living relatives. So the question shifts. If intelligence can arise in one dinosaur lineage, birds, could a non-avian branch have evolved even higher cognitive complexity given enough evolutionary pressure and time? Paleontologist Dale Russell once speculated, somewhat controversially, about what a highly intelligent troodontid dinosaur might have looked like if the extinction event had not occurred. Troodontids had relatively large brain-to-body ratios compared to other dinosaurs. Russell imagined a humanoid-like dinosauroid, with upright posture and dexterous hands. The idea sparked fascination and criticism. Evolution does not necessarily trend toward humanoid shapes. Convergent evolution can produce similar solutions under similar pressures, but it is not a guarantee of bipedal philosophers with scaly skin. Historians still argue whether intelligence comparable to humans is an inevitable evolutionary outcome under the right conditions, or whether it is a rare fluke shaped by a highly specific chain of accidents. Consider the requirements for industrial civilization as you understand it. You need not only intelligence, but manipulative appendages capable of fine motor control, access to concentrated energy sources, Social cooperation on large scales. Environmental pressures that reward technological innovation. Many dinosaurs lacked hands suited for precision grip. Claws are excellent for hunting or defense, not so ideal for threading a needle. But some theropods had grasping forelimbs. And birds, again, demonstrate that beaks and feet can manipulate objects in surprisingly refined ways. Still, there is no fossil evidence of dinosaur-built tools beyond occasional bite marks or nesting behavior. No carved stone implements. No metal residues. No anomalous alloys embedded in Cretaceous rock layers. If a technologically advanced dinosaur civilization had existed during the Mesozoic, you might expect at least indirect signs, unusual isotope anomalies, strange material concentrations, something beyond natural explanation. So far, nothing of the sort has been found, and the fossil record of the Mesozoic is extensive. You have vast sedimentary deposits from that era rich in bones, footprints, eggs, and plant fossils. Paleontologists have reconstructed entire ecosystems in exquisite detail. If there were cities of any substantial scale, you would likely see disturbances, unnatural stratification, concentrated debris fields. Instead, what you see are river deltas, floodplains, forests, volcanic ash layers. Nature, uninterrupted by industry. There's also a deeper biological consideration. Dinosaurs occupied ecological niches that were already highly successful. For tens of millions of years, they thrived without needing to radically alter their environment through technology. Evolution rewards what works. If claws and teeth are sufficient, there is little pressure to invent smelting. You, on the other hand, evolved in fluctuating climates, facing resource variability and competition that may have favored adaptability and tool use. Opposable thumbs, stereoscopic vision, and complex social structures gave you a peculiar edge. But, and here's the humbling twist, your industrial civilization has existed for an almost negligible fraction of your species' timeline. For most of human history, you were hunter-gatherers too. Agriculture arose around 10,000 years ago. Writing appeared around 5,000 years ago. Electricity and fossil fuel-powered industry? Yesterday, in geological terms. If an asteroid had struck Earth 100,000 years ago, Homo sapiens would never have developed cities. Future paleontologists might have found stone tools and campfire remnants, but nothing suggesting satellites or skyscrapers. So when you imagine dinosaurs building cities, you must remember how fragile and contingent your own technological leap has been. Intelligence alone is not enough. Timing matters. Catastrophe matters. Stability matters. The Chicxulub asteroid effectively reset the evolutionary board. Mammals, previously small and mostly nocturnal, diversified rapidly afterward. Without that impact, dinosaurs might still dominate terrestrial ecosystems today. But domination does not equal industrialization. You stand now in a Cretaceous forest, listening to distant roars and the rustle of massive bodies moving through undergrowth. The world feels ancient, immense, and entirely organic. No smokestacks pierce the canopy. No highways cut through ferns. Could intelligence have flickered briefly in some dinosaur lineage, rising and vanishing without leaving clear trace? Theoretically, perhaps. But the absence of supporting geological or fossil evidence makes it extraordinarily unlikely. Sometimes the most honest answer is the simplest one. The fossil record shows no sign of pre-human industrial civilizations in the age of dinosaurs. Still, the question serves a purpose. It reminds you how much of Earth's history unfolded without you. For 165 million years, life thrived, adapted, evolved, without factories, without writing, without late-night existential podcasts. And that realization does something gentle to your ego. You are not the inevitable pinnacle of a straight line. You are one branch on a wildly branching tree, lucky enough to have survived long enough to ask whether anyone climbed here before you. You leave the Cretaceous forest behind and rise upward, far upward, until continents become shapes, and shapes become slow-moving rafts drifting on a restless mantle. The ground beneath your feet, which once felt solid and trustworthy, now reveals itself as something thinner and more fragile than you imagined. Earth's crust is not a permanent stage. It is a conveyor belt. Plate tectonics, formally accepted in the late 1960s, transformed geology from descriptive storytelling into a dynamic planetary narrative. The lithosphere, the rigid outer shell of Earth, is broken into tectonic plates that move a few centimeters per year. That sounds gentle. Your fingernails grow faster. But over millions of years, those centimeters become oceans. Oceanic crust forms at mid-ocean ridges and is recycled at subduction zones. Continental crust collides, crumples into mountain ranges, and sometimes splits apart. Supercontinents assemble and fragment. Pangaea, which formed about 335 million years ago, began breaking apart around 175 million years ago. Before Pangaea, there were others, Rodinia, Nuna, lost configurations of land and sea. If you are searching for the ruins of a civilization tens or hundreds of millions of years old, you must reckon with this. The ground itself does not stay put. Oceanic crust, as you've heard, rarely survives beyond 200 million years. It is continuously subducted into the mantle, where heat and pressure transform it beyond recognition. Any coastal cities built upon it would not merely erode, they would be dragged downward, melted, and reincorporated into magma. Continental crust lasts longer. Some portions are over 4 billion years old. But even continents are reshaped. Mountain building events, like the collision that formed the Himalayas beginning around 50 million years ago, metamorphose rock under extreme pressure and temperature. Sedimentary layers can be folded, faulted, or recrystallized into entirely new forms. Historians still argue whether certain enigmatic rock formations once interpreted as purely natural might include subtle biological influences that were later overprinted by metamorphism. The deeper you go into geological time, the more the record blurs. Imagine a city built 300 million years ago on what is now eastern North America. At that time, the region sat near the equator as part of Pangaea. Over eons, that landmass shifted, split, eroded. The Appalachian Mountains rose and were worn down. Layers piled atop one another. Any surface structure would have been buried, compressed, possibly metamorphosed into schist or gneiss. Recognition becomes nearly impossible. There's a quirky geological concept called the Great Unconformity. In certain places, vast spans of geological time, hundreds of millions of years, are simply missing from the rock record. Erosion stripped them away before newer layers were deposited. It's like tearing entire chapters from Earth's diary and tossing them into the wind. You stand at the edge of the Grand Canyon, where such unconformities are visible. Layers jump abruptly from ancient crystalline basement rock to much younger sedimentary strata. Missing time, silent and unaccounted for. If a civilization had existed during one of those missing intervals, its physical traces could have been erased entirely. Not hidden. Not waiting. Erased. But erasure is not selective. It removes natural and artificial alike. The absence of evidence in such gaps does not secretly favor lost empires, it simply reflects geology's indifference. Still, the scale humbles you. You imagine future geologists, human or otherwise, studying a cross-section of Earth tens of millions of years from now. They might see a thin Anthropocene layer rich in carbon anomalies and microplastics, compressed between older Holocene sediments and whatever comes next. If plate tectonics eventually drags part of that layer into subduction zones, it too will vanish. Perhaps only fragments preserved on stable continental interiors will remain. And here's an almost unfair twist: erosion does not act uniformly. Some regions preserve ancient rock beautifully, cratons that remain relatively stable for billions of years. Others are geological battlegrounds of uplift and destruction. Preservation is a matter of luck as much as durability. You let your gaze soften as continents drift in slow motion beneath you. Africa inches northward. Australia glides steadily towards Southeast Asia. The Pacific Ocean shrinks as subduction zones consume its floor. Given enough time, entirely new supercontinents will form. Some models predict a future assembly called Amasia or Pangaea Proxima in hundreds of millions of years. If your civilization's remnants survive that long, they will be folded into mountain belts of a world no human has seen. There is something strangely comforting in this scale. You worry about whether anyone came before you, but Earth's surface has been rewritten so many times that even if they had, their script might have been overwritten repeatedly. Historians still argue whether humanity underestimates the sheer power of geological recycling when imagining deep time mysteries. You tend to picture Earth as a static archive. In reality, it is more like a chalkboard being wiped clean and rewritten over and over. You feel yourself settling, the urgency of the question softening. If there was a civilization before you, millions of years ago, plate tectonics alone could have erased nearly all direct physical evidence. Not because it was secret. Not because it was suppressed. Simply because continents move, mountains rise, and rock flows slowly like thick honey under unimaginable pressure. The planet is not a museum curator. It is a sculptor who never stops chiseling. And as you drift in this planetary perspective, continents sliding gently across a molten underworld, the possibility of forgotten ages feels less dramatic and more natural. Things arise. Things vanish. The crust folds. Time continues. You are just one layer among many. You lift your eyes from the drifting continents and look upward, past the clouds, past the thin blue line of atmosphere, into the black stillness where something very different waits. The moon hangs there, pale and unblinking. Unlike Earth, the moon has no plate tectonics, no active weather, no oceans to churn and recycle its surface. Its crust is ancient and largely undisturbed. Some lunar regions are over 4 billion years old. Footprints left by Apollo astronauts in 1969 may persist for millions of years, softened only by micrometeorite impacts. It's the closest thing you have to a time capsule in the sky. Mainstream planetary science confirms that the moon lacks the dynamic resurfacing processes that constantly rewrite Earth's crust. No wind. No rain. No subduction zones. Just slow accumulation of dust and the occasional impact scar. So a curious thought emerges. If a technological civilization had existed on Earth millions of years ago and had achieved spaceflight, might traces of its activity survive better on the moon than on Earth? It's a bold step, but a logical one. You imagine an ancient species reaching orbit, planting instruments, perhaps even constructing small structures on the lunar surface. On Earth, their cities erode and subduct. On the moon, their artifacts sit quietly in vacuum. Historians still argue whether searching the moon and other stable planetary bodies for technosignatures of past extraterrestrial civilizations is a worthwhile scientific endeavor. Some researchers suggest scanning for unusual metallic concentrations or geometric anomalies inconsistent with natural impact processes. So far, no credible evidence of alien or ancient artifacts has been found on the moon. High-resolution imaging from lunar orbiters has mapped vast swaths of its surface in remarkable detail. You see craters, lava plains, ridges, geology shaped by impacts and ancient volcanism. Nothing that screams, forgotten launchpad. Still, the contrast between Earth and Moon is instructive. On Earth, rain falls. Rivers carve valleys. Tectonic plates collide and dive. Even mountain ranges are temporary. On the Moon, a footprint lingers. There's a quirky but real example of long-term preservation off Earth. The Voyager Golden Records, launched in 1977 aboard the Voyager spacecraft. They carry sounds and images of Earth, encoded in gold-plated copper discs designed to last for potentially billions of years in interstellar space. Barring collision, they may outlive mountains, oceans, perhaps even your species. You smile softly at the irony. Your most durable archive may not be on Earth at all. If a pre-human civilization had reached space and placed durable artifacts beyond Earth's atmosphere, those artifacts might still exist. Not on your planet's restless crust, but in orbit, on the moon, or drifting between planets. But here's the sober grounding. Achieving spaceflight requires an industrial base. It requires metallurgy, chemistry, energy concentration, and a deep understanding of physics. If such a civilization had reached that level, it likely would have left detectable industrial signatures on Earth first: carbon anomalies, synthetic compounds, altered isotope ratios. You return mentally to the Silurian hypothesis. The idea isn't that evidence would be cinematic, it's that it would be chemical. The moon adds another dimension to the puzzle. It reminds you that preservation depends on environment. Earth is alive geologically. The moon is quiet. Imagine, for a moment, that you are a future species evolving on Earth 200 million years from now. You detect a thin anomalous layer in ancient rock, carbon spikes, microplastics, perhaps unusual nitrogen signatures. It suggests something happened. But it's ambiguous. Then you develop spaceflight and explore your moon. There, half buried in regolith, lies a corroded satellite frame or a strange alloy fragment inconsistent with lunar geology. Suddenly, ambiguity sharpens into narrative. It's speculative, yes. But it illustrates a principle: off-world environments preserve differently. Historians still argue whether humanity should deliberately create long-lasting markers, on the moon, in orbit, even on stable asteroids, to ensure that future intelligences know you were here. It's a modern echo of carving messages in stone, just with rockets. You glance again at the moon. Its surface is pockmarked with impact craters, some overlapping in complex patterns. Without atmosphere or erosion, those scars remain visible for eons. It is a gallery of cosmic history. Earth, by contrast, hides most of its oldest impact craters. The Chicxulub crater, which ended the dinosaurs 66 million years ago, was only confirmed in the late 20th century through geophysical surveys. On the moon, it would have been obvious. If a civilization once thrived on Earth, your best chance of finding its most durable traces might not lie beneath your feet, but above your head. And yet, there is no evidence of such traces. Lunar missions, telescopic surveys, orbital imaging, none have revealed artifacts predating humanity. The silence is meaningful. Still, the thought lingers gently, like moonlight on water. Preservation is not about importance. It's about context. On Earth, even empires become sediment. On the moon, footprints linger. You feel your perspective stretching again, beyond continents, beyond oceans, into the quiet black where time accumulates differently. If you are not the first civilization on Earth, the planet may have erased your predecessors' cities. But the cosmos is vast, and preservation can occur in unexpected places. For now, though, the moon remains what it has always appeared to be: a silent companion, reflecting sunlight and holding its secrets, if any, without commentary. And beneath its steady glow, Earth continues its slow, relentless reshaping. You lower your gaze from the moon and return to Earth, but not to cities or coastlines. Instead, you stand at the edge of a mass extinction. The air feels heavy. The oceans are unsettled. Species that once thrived are thinning, disappearing, leaving behind only scattered bones and empty ecological niches. If a prior civilization existed, might its shadow hide within one of these great die-offs? Earth has experienced 5 major mass extinctions in the last 540 million years, the so-called Big Five. The End-Ordovician, Late Devonian, End-Permian, End-Triassic, and End-Cretaceous events each wiped out significant percentages of species. The End-Permian extinction, about 252 million years ago, was the most severe, eliminating roughly 90% of marine species and 70% of terrestrial vertebrate species. Mainstream geology attributes the End-Permian event primarily to massive volcanic eruptions in what is now Siberia, the Siberian Traps. These eruptions released enormous amounts of carbon dioxide and other gases, triggering global warming, ocean acidification, and widespread anoxia. No factories required. Just lava. Lots of lava. Still, you pause and consider the pattern. A rapid carbon spike. Global warming. Ocean chemistry shifts. Biodiversity collapses. It sounds uncomfortably familiar. Historians still argue whether the precise chain of events during certain mass extinctions unfolded in pulses or as one prolonged catastrophe. The rock record preserves clues, but not always with perfect resolution. Layers blur. Timelines compress. If a hypothetical industrial civilization had significantly altered the climate, could it have contributed to, or been caught within, such an extinction event? It's a delicate question. The fossil record of mass extinctions shows clear natural drivers: flood basalts, asteroid impacts, shifts in ocean circulation, methane releases. There is no credible evidence of manufactured materials, synthetic compounds, or engineered structures associated with these ancient die-offs. No anomalous alloys in Permian strata. No plastic fragments in Devonian shale. And yet, you notice something subtle. Mass extinctions leave signatures not just in what disappears, but in what proliferates afterward. Following the end Cretaceous extinction 66 million years ago, the one that ended the non-avian dinosaurs, mammals diversified dramatically. Ecological niches emptied by extinction become evolutionary opportunities. If a prior civilization had existed and collapsed due to environmental mismanagement, you might expect to see abrupt biodiversity loss followed by adaptive radiation of surviving species. But that pattern already exists in purely natural events. Nature does not need industry to trigger upheaval. There's also a quirky geological detail that complicates dramatic narratives. Some extinction events unfolded over hundreds of thousands of years. That's catastrophic in geological terms, but glacial in human ones. It's less overnight apocalypse and more very bad millennia. Hard to blame on a weekend of reckless fossil fuel use. You walk through a fossil-rich outcrop in your imagination. Brachiopod shells embedded in limestone. Trilobite fragments scattered through shale. Above them, a thin boundary layer marks a sudden change. Fewer species, different assemblages. The Cretaceous-Paleogene boundary, dated to 66 million years ago, includes a global layer enriched in iridium, an element rare in Earth's crust but common in asteroids. That iridium spike was one of the key pieces of evidence confirming the asteroid impact hypothesis. It's a crisp, global signal. If a prior industrial civilization had triggered a mass extinction, you might expect an equally crisp marker, something globally anomalous and difficult to explain through natural processes. So far, none has been found in pre-human strata. Historians still argue whether humanity is currently driving a sixth mass extinction. Species are disappearing at rates far above background levels due to habitat loss, climate change, pollution, and overexploitation. The fossil record millions of years from now may show a sharp reduction in biodiversity around your era. You feel the weight of that realization. If future paleontologists, human or otherwise, study this period, they may not see your cities clearly. But they may see the abrupt disappearance of countless species, coinciding with a carbon isotope anomaly and unusual sediment chemistry. Your fingerprint may not be architectural. It may be biological. You sit with that for a moment. If a prior civilization had existed and triggered ecological collapse, its clearest legacy might not be ruins, it might be extinction patterns. But extinction patterns alone are insufficient evidence of industry. Volcanoes and asteroids can do the same. The burden of proof remains high. Extraordinary claims require extraordinary markers. And yet, you cannot ignore the symmetry. Life has risen and fallen repeatedly on this planet. Each time, the survivors reshape the world. You imagine standing at the edge of the Permian extinction, watching ecosystems unravel. Forests wither. Oceans stagnate. Creatures adapted to stable conditions falter. Whether caused by volcanism or hypothetical industry, the result feels similar: imbalance, then reset. There's a strange comfort in recognizing that Earth has endured far worse than anything humans have yet unleashed. The planet survived asteroid impacts and supervolcanoes. It will survive you. The question is not whether Earth can recover. It's whether a civilization caught in such upheaval can. If there were others before you, intelligent, industrious, they too would have been vulnerable to the same forces that shaped these extinctions. You brush your hand across the fossil layer once more. The shells are silent. They do not whisper of factories or engines. They speak of ecosystems, complex, interdependent, fragile. And as you rise from the outcrop, you begin to understand that the clearest trace any civilization leaves may not be in stone or metal, but in the living web it disturbs. Whether you are first or not, you are certainly not immune. You remain at the edge of extinction, but now your focus narrows, not to bones in rock, but to the invisible chemistry of the air itself. You inhale slowly. Nitrogen, oxygen, traces of argon, and just over 420 parts per million of carbon dioxide. That number has become strangely famous in recent years. Atmospheres remember. Long after cities crumble and coastlines shift, the gases you release leave isotopic fingerprints. When you burn fossil fuels, coal, oil, natural gas, you release carbon that has been locked underground for hundreds of millions of years. That carbon is isotopically lighter, meaning it contains relatively more carbon-12 than carbon-13. As a result, the ratio of carbon isotopes in the atmosphere shifts measurably. This is not speculation. It is directly observed. Ice cores, tree rings, and atmospheric sampling all confirm that the modern rise in CO2 carries the distinct isotopic signature of fossil fuels. If your civilization vanished tomorrow, that isotopic anomaly would settle into sediments and carbonate shells, potentially detectable for millions of years, assuming it isn't overprinted by later processes. So if you are searching for a prior industrial age, atmospheric scars are among the most promising clues. Historians still argue whether certain ancient carbon isotope excursions, like those during the Paleocene-Eocene thermal maximum, were driven entirely by natural processes or involved feedbacks not yet fully understood. But so far, every known deep-time carbon spike has plausible geological explanations: volcanism, methane hydrate release, organic carbon oxidation. Nature is more than capable of dramatic chemistry. Still, you imagine a scenario. An intelligent species evolves during a stable climatic window. It discovers concentrated energy sources, perhaps fossil fuels of its own era. It begins burning them, altering atmospheric composition. CO2 rises. Oceans acidify. Weather patterns shift. Sound familiar? The key question becomes scale and duration. Your industrial surge has unfolded over about 200 years. That speed is geologically abrupt. If such a spike occurred in the deep past and lasted only a few thousand years before collapse, its signal might be thin, compressed into a narrow sedimentary layer. But if it persisted for hundreds of thousands of years, the anomaly would be thicker, more obvious. There's also nitrogen. Modern agriculture relies heavily on synthetic fertilizers produced through the Haber-Bosch process, developed in the early 20th century. This process fixes atmospheric nitrogen into ammonia at industrial scales, dramatically altering the global nitrogen cycle. That alteration leaves isotopic traces as well. Future geologists might see a sudden, unusual shift in nitrogen isotopes in sediments corresponding to widespread fertilizer use. Quirky detail: before the Haber-Bosch process, global agriculture depended on natural nitrogen sources like guano deposits and crop rotation. One 19th century fear was that civilization might collapse simply from running out of fertilizer. Instead, you industrialized the sky. If a prior civilization had similarly altered its planet's nitrogen cycle, you might expect comparable isotopic disturbances. Yet, no such anomalous patterns have been clearly identified in pre-human geological records. Then there are persistent organic pollutants, synthetic chemicals like PCBs or certain chlorinated compounds. Many are resistant to natural breakdown. However, over tens of millions of years, even these can degrade or transform under heat and pressure. Historians still argue whether any synthetic compound produced today could remain chemically recognizable after, say, 50 million years of burial and metamorphism. Some believe fragments or altered derivatives might persist. Others suspect most would be indistinguishable from natural organic residues. You tilt your head and consider oxygen. Around 2.4 billion years ago, during the Great Oxidation Event, atmospheric oxygen levels rose dramatically due to photosynthetic microbes. That shift permanently altered Earth's chemistry. It left unmistakable signatures in banded iron formations. But that transformation was biological, not industrial. Life itself reshaped the atmosphere long before intelligence arrived. It's a humbling reminder: you are not the first entity to transform the sky. You are simply doing it faster. And speed may be your defining trait. If a prior civilization existed, one of the strongest indicators would be a rapid, global atmospheric shift inconsistent with known natural mechanisms. But so far, the rock record shows patterns that align well with volcanism, tectonics, orbital cycles, and biological evolution. That doesn't make the search foolish. It refines it. You imagine a future scientist analyzing a sediment core from your era. They note a sharp CO2 spike, a concurrent nitrogen shift, microplastic residues, perhaps traces of heavy metal enrichment. They debate whether this cluster of anomalies can be explained by natural processes alone. The combination becomes key. One anomaly might be volcanic. Two might be coincidence. But a synchronized suite of industrial signatures would be harder to dismiss. As of now, no such synchronized, unmistakably artificial suite has been found in ancient strata predating humans. You exhale again, feeling the weight of the atmosphere pressing gently around you. It seems so intangible, yet it is one of the most durable archives of planetary change. If you are not the first civilization, then either your predecessor left atmospheric scars indistinguishable from nature's own experiments, or their industry never reached global scale. Or perhaps it never existed at all. The air does not answer. It simply circulates, mixes, equilibrates. But you cannot shake the realization that if any evidence of a forgotten age lingers, it is most likely written not in ruins or myths, but in ratios of invisible gases, patiently waiting in stone. And as you drift in that thought, the sky above you feels less like empty space and more like a ledger, quietly recording every imbalance, every experiment, every breath. You step away from chemistry and into a museum storage room. Not the glossy exhibit hall with dramatic lighting and polished placards, but the quiet back rooms, where shelves stretch in long rows and boxes are labeled in careful handwriting. Most artifacts spend their lives here, catalogued and waiting. Archaeology, you realize, is not just about what is found. It's about what is recognized. If a prior civilization existed, its traces might not leap out at you with flashing neon signs. They might sit misidentified in a drawer, or dismissed as natural formations, or never excavated at all. Mainstream archaeology operates within frameworks, carefully built models of how societies develop based on accumulated evidence. Stone tools precede metallurgy. Nomadic bands precede cities. Agriculture supports population density. These models are not arbitrary. They are grounded in thousands of excavations across continents. But frameworks can also create blind spots. Historians still argue whether early 20th century archaeologists underestimated the sophistication of non-European cultures due to bias. Sites in Africa, the Americas, and Oceania were sometimes interpreted through colonial assumptions rather than evidence. Over time, many of those interpretations were corrected. Complexity was recognized where it had been overlooked. That history serves as a caution. Your interpretations are shaped by expectation. There's a quirky example that illustrates this beautifully: the Antikythera mechanism. Discovered in a shipwreck off the Greek island of Antikythera in 1901, it looked at first like a corroded lump of bronze. Only decades later did detailed study reveal it to be an intricate ancient Greek analog computer, dating to around 100 BCE, capable of predicting astronomical positions and eclipses. It was not evidence of a lost global supercivilization. It was evidence that ancient engineers were more sophisticated than previously assumed. But for years, it sat as an enigma because no one expected such complexity from that era. Recognition lagged behind reality. Now imagine encountering an anomalous rock layer containing unusual mineral structures. If you expect purely natural explanations, you will first search for volcanic, sedimentary, or biological processes. And rightly so, because natural processes account for the overwhelming majority of geological features. But the thought experiment lingers: Could something artificial be overlooked because it does not fit current expectations? The scientific method guards against this by demanding multiple lines of evidence. Extraordinary claims must survive scrutiny, replication, peer review. That's a strength, not a weakness. It prevents every oddly shaped rock from becoming a lost temple. Still, funding and focus shape discovery. Excavations require resources. Remote ocean floors and deeply buried strata are expensive to explore. You have mapped only a fraction of Earth's subsurface in high resolution. Historians still argue whether the archaeological record is inherently biased toward durable materials, stone, pottery, bone, while overlooking organic or ephemeral technologies that might have characterized some societies. If a civilization relied heavily on biodegradable materials, its visible footprint could be faint even after a few thousand years. Now stretch that to millions. You picture a civilization that built with advanced composites derived from biological polymers, materials strong in their time but prone to degradation under heat and pressure. Their cities might dissolve into chemically altered sediments indistinguishable from natural deposits. It sounds convenient, almost too convenient. And that's where caution re-enters. You must avoid turning every gap in knowledge into a hiding place for fantasy. The absence of evidence is not an invitation to fill the void with whatever feels intriguing. It is simply absence. There's also the scale problem again. Archaeology excels at studying the last few million years, particularly the last 100,000. Beyond that, you move from archaeology into paleontology and geology. The tools and questions shift. You are no longer looking for pottery shards but for fossilized ecosystems. If a pre-human civilization existed tens of millions of years ago, its traces would not be in museum drawers labeled miscellaneous artifacts. They would be embedded in deep geological strata. The expertise required to identify them would cross disciplines: geochemistry, sedimentology, isotope analysis. You wander between the shelves, noticing how many artifacts remain understudied. There are always more finds than specialists to analyze them. That reality fuels imagination. What if something extraordinary sits unnoticed? But extraordinary patterns, if real, tend to ripple outward. They appear in multiple sites, multiple contexts. Science advances not by single mysterious objects, but by converging lines of evidence. So far, no such convergence points toward a pre-human industrial civilization. Still, humility remains essential. You once believed agriculture was the clear starting line of complexity. Göbekli Tepe revised that. You once assumed ancient engineers were limited in precision. The Antikythera mechanism challenged that. Each correction refined your model. None required hidden continents or secret global empires, just patience and better tools. Perhaps that is the quiet lesson here. If you are not the first civilization, the evidence must align across geology, chemistry, and paleontology. It cannot rest on a single puzzling artifact or ambiguous formation. It must survive skepticism. As you leave the storage room, you feel both reassured and curious. Science is not a gatekeeper of dogma, it is a filter for noise. It discards what cannot be supported and strengthens what can. If something extraordinary lies buried in deep time, it will not remain hidden forever. It will emerge gradually, through careful measurement and cross-checking, not through dramatic revelation. Until then, the shelves remain filled with human history, and the deeper layers of Earth remain patient, waiting for better questions. You step out of the museum storage room and into a different kind of landscape, one made not of rock or bone, but of ideas. This is where curiosity can either sharpen into insight or wander off into mirage. If you are going to ask whether you are the first civilization on Earth, you must also learn how to separate wonder from wishful thinking. Fringe theories flourish in the fertile soil between mystery and misunderstanding. The moment you say, "We don't know everything," someone eagerly replies, "Exactly, and therefore, Atlantis had Wi-Fi." It's almost charming. Almost. Take the recurring claim that ancient nuclear wars occurred in deep antiquity. Proponents sometimes point to natural glass formations, like trinitite, formed during modern nuclear tests, and suggest that similar glassy materials found in deserts must be evidence of prehistoric detonations. But mainstream geology explains many of these formations through lightning strikes, meteor impacts, or volcanic processes. Libyan desert glass, for instance, is widely believed to have formed from a meteor airburst around 29 million years ago. It's dramatic, yes, but natural. No ancient launch codes required. Historians still argue whether the human tendency to favor catastrophic, technologically dramatic explanations reflects modern cultural bias. You live in an age of engines and explosions, so you project engines and explosions backward. There's also the allure of out-of-place artifacts, objects allegedly discovered in strata far older than their supposed age. Most such claims dissolve under scrutiny. Misdated layers. Intrusive burials. Modern contamination. The scientific process is slow precisely because it demands verification. You pause and let that settle. Skepticism is not cynicism. It is care. The Silurian Hypothesis, remember, was not proposed to claim that reptilian industrialists once ran coal plants. It was posed to ask a methodological question: what would count as evidence? It strengthens science by clarifying detection limits. Fringe narratives often skip that step. They leap from anomaly to conclusion without building the bridge in between. There's a quirky but revealing example in astronomy. For decades, scientists puzzled over unusual pulsating radio signals detected in 1967. The signals were so regular that they were jokingly labeled LGM, for Little Green Men. But further study revealed they were pulsars, rapidly rotating neutron stars. Anomaly first. Extraterrestrial speculation second. Natural explanation confirmed. The lesson isn't that extraterrestrials are impossible. It's that nature frequently produces phenomena stranger than imagination. So when someone claims that pyramids align too perfectly with stars to be human-made, or that erosion patterns prove an advanced Ice Age civilization, you return to evidence. Measurement. Replication. Context. Historians still argue about the pace and pathways of cultural development, but there is broad consensus that no credible, reproducible evidence supports the existence of a technologically advanced pre-human civilization. That does not close the door on curiosity. It simply narrows the hallway. You imagine two paths diverging. One path embraces every unexplained detail as confirmation of hidden grandeur. The other path accepts uncertainty without rushing to fill it. The second path is quieter, less dramatic, but more resilient. There's also a psychological comfort in believing you are not the first. If others rose and fell before you, perhaps your own fragility feels less lonely. If ancient supercivilizations once thrived and vanished, then your current anxieties become part of a cosmic pattern rather than a singular crisis. But comfort is not evidence. You sit with that gently. The real wonder is not diminished by skepticism. In fact, it deepens. The idea that simple physical laws, gravity, thermodynamics, plate tectonics, can shape worlds so dramatically is astonishing enough. You do not need hidden empires to make Earth mysterious. And yet, the disciplined question remains valid. If evidence one day emerges, clear, convergent, undeniable, you must be willing to revise your understanding. Science is not dogma. It is revision in motion. The key is proportion. Extraordinary claims require extraordinary evidence. That phrase is often repeated, sometimes smugly, but its core is humility. The more a claim overturns established understanding, the stronger the evidence must be. So far, every robust line of geological and paleontological evidence supports the view that you are the first species on Earth to develop large-scale industrial technology. That conclusion is not arrogant. It is provisional. It rests on available data. You breathe in slowly. Curiosity and skepticism are not enemies. They are partners. Curiosity asks bold questions. Skepticism ensures the answers are sturdy. If you are not the first civilization, the truth will not hide forever. It will leave measurable scars, chemical, geological, biological, that withstand scrutiny. Until then, the balance remains: wonder without gullibility, openness without surrendering rigor. And in that balance, you continue the search, not because you crave sensational revelations, but because you value understanding. The Earth is mysterious enough. You do not need to invent ghosts in its strata. Now, having sifted through rocks and myths and extinctions and isotopes, you allow yourself one final imaginative stretch, not as assertion, not as claim, but as possibility. If you were not the first civilization on Earth, who were they? You resist the temptation to picture humanoids in slightly different costumes. Evolution does not owe you symmetry. If intelligence arose before in deep time, it might have worn a shape you would barely recognize. Perhaps it evolved in the oceans. After all, life began there. For most of Earth's history, complex ecosystems were marine. Cephalopods, octopuses and their relatives, already display remarkable intelligence today. They solve puzzles, open jars, and exhibit playful behavior. Quirky detail: octopuses have distributed nervous systems. Much of their neural processing occurs in their arms. It's as if your hands could think independently and occasionally disagree with you. Which, to be fair, sometimes feels accurate even now. Imagine an ancient cephalopod lineage, given tens of millions of stable years, evolving increasingly complex cognition. Could such a species develop technology underwater? Fire would be problematic, yes. Metallurgy becomes tricky when your workshop is damp. But intelligence need not mirror your path. Perhaps chemistry, bioengineering, or pressure-based technologies would emerge instead. Historians still argue whether tool use and industrialization are inevitable outcomes of intelligence, or whether they depend heavily on environmental context, availability of fire, accessible metals, stable land surfaces. Your own technological explosion required exposed continents, oxidizing atmosphere, concentrated fossil fuels. A marine civilization might follow entirely different rules. And if it collapsed, its remnants would likely dissolve quickly in dynamic ocean sediments. Or perhaps intelligence bloomed briefly among terrestrial reptiles before the end Cretaceous asteroid. Not humanoid dinosauroids, but some clever, social lineage experimenting with environmental manipulation. Without opposable thumbs, perhaps they shaped tools with jaws or feet. It sounds far-fetched, but so would your own existence if described to a Devonian trilobite. Still, the fossil record shows no evidence of such complexity. No anomalous tool marks. No engineered structures embedded in Mesozoic rock. If such a civilization existed, it left no clear paleontological signature. You consider a quieter possibility. What if a pre-human civilization never reached industrial scale? Perhaps it plateaued at something equivalent to your Bronze Age, localized cities, early metallurgy, modest population. Such a society might leave artifacts detectable for thousands, even hundreds of thousands of years, but over tens of millions, erosion and tectonics would likely erase nearly everything. Without global atmospheric alteration, its chemical footprint would be faint. Without synthetic polymers or radioactive byproducts, its markers would blend into natural background levels. In that case, you might truly never know. There is something strangely humbling in that thought. Not dramatic lost superpowers, just a brief experiment in complexity, extinguished by climate shift or volcanic upheaval, leaving behind nothing more than a slightly unusual sediment layer now long recycled into mantle. Historians still argue whether intelligence itself is a convergent feature of evolution, likely to arise repeatedly under similar pressures, or whether it is an improbable accident. On Earth, complex multicellular life took billions of years to appear. Tool-using intelligence emerged only once, as far as current evidence shows. That uniqueness could mean you are first. Or it could mean previous experiments were rare and short-lived. You imagine a species evolving on a now vanished coastline 150 million years ago. They look nothing like you. They communicate in ways you cannot fathom: vibrations, color shifts, chemical signals. They shape their environment subtly, perhaps even developing rudimentary energy harnessing. Then tectonics shift. Sea levels rise. Climate destabilizes. An asteroid strikes. Their lineage ends. No libraries fossilized. No satellites orbiting. Just ecosystems rebalancing. It feels less like science fiction and more like quiet tragedy. But then you return to evidence. So far, every measurable line of geological and fossil data suggests that no such industrial, or even proto-industrial civilization existed before humans. The patterns you see, mass extinctions, carbon spikes, metal deposits, are well explained by natural processes. Imagination is powerful, but it must bow to data. Still, allowing yourself to picture alternatives changes how you see your own place. You are not guaranteed permanence. Intelligence is not immune to extinction. Civilization is not a stable state, it is a temporary arrangement of energy and cooperation. If others came before you, they vanished without a trace you can clearly detect. If none did, you are still bound by the same physical laws that would have erased them. You feel the weight of that symmetry. Whether first or not, you are fragile. And perhaps that is the deeper value of the question. It shifts your perspective from pride to responsibility. If you are the only civilization this planet has ever hosted, that is extraordinary. If you are one of several experiments across deep time, that is equally extraordinary, and equally sobering. You stand at the edge of imagination, looking back across millions of years. The Earth offers no portraits of prior architects, no fossilized blueprints. Only rock. Only chemistry. Only silence. And in that silence, you begin to sense that the more important question may not be who came before you, but who will come after. You turn your gaze forward now, beyond ancient seas and vanished forests, beyond pyramids and pillars, beyond isotopes and extinctions. The question gently flips in your hands. If you are not the first civilization on this earth, what will future civilizations think of you? Imagine a world 50 million years from now. Continents have shifted again. Perhaps Africa has fused with Europe completely. Perhaps a new supercontinent is assembling near the poles. Mountain ranges you know are gone, ground down to sediments and lifted elsewhere in unfamiliar forms. Somewhere in that future landscape, a curious species walks across an exposed cliff face. They are intelligent. However that intelligence manifests. They study the rock layers carefully, just as you do now. They find a thin band dating to roughly 200,000 years in duration, a geological blink. Within it, they detect a rapid carbon isotope excursion, a sharp nitrogen anomaly, elevated concentrations of certain metals, and faint residues of synthetic polymers altered by time and pressure. They debate. Historians, if they call themselves that, still argue whether this anthropic pulse, as they might name it, represents a natural hyperthermal event or something more peculiar. The data show abrupt warming, widespread species turnover, and strange material signatures not easily explained by volcanism alone. They do not find skyscrapers. They do not unearth intact highways. They see chemistry. Perhaps, in rare stable cratons, fragments of plastiglomerate remain, melted plastic fused with sand and shell. Perhaps fossilized chicken bones appear in astonishing abundance, a sudden spike of one peculiar avian form distributed globally. The dominant megafauna of your age immortalized in sediment. It's almost comical. You reshape the planet, and your legacy is poultry. But the pattern intrigues them. They model atmospheric changes. They reconstruct ancient coastlines. They discover a sharp spike in radioactive isotopes corresponding to a brief period of nuclear activity. It decayed long ago, but isotopic daughter products hint at something unusual. They begin to suspect. Was there, they ask, a species capable of harnessing fossil carbon at planetary scale? A species that altered nitrogen cycles, scattered polymers across oceans, and then faded? They search for corroboration. They examine lunar archives, if they too have reached space. On the moon, perhaps they find the faint outline of a long-buried lander, partially obscured by micrometeorite dust but still geometrically distinct from natural formations. Suddenly, ambiguity sharpens into story. You imagine their quiet realization. We were not first. And in that moment, across tens of millions of years, a thread connects you. Not through myth. Not through preserved monuments. But through shared inference. Through curiosity applied to stone. There's something deeply calming in that symmetry. You once stood on your own world and wondered if someone came before. One day, someone, or something, may stand on theirs and wonder about you. Historians still argue whether intelligence is fleeting or self-limiting. Some propose that technological civilizations tend to collapse before mastering sustainability. Others suggest that long-term survival requires learning planetary restraint. You are living inside that experiment. From deep time's perspective, your entire industrial age is a flash, a sudden flare in atmospheric chemistry, a rapid rearrangement of biomass, a brief surge of metal and plastic. Whether that flare stabilizes or extinguishes remains unwritten. The Earth does not guarantee second chances. It simply provides conditions and responds to feedback. If you are the first civilization, then you carry singular responsibility. If you are one of several across deep time, then you are part of a rare pattern, intelligence flickering in geological darkness. Either way, permanence is not promised. You feel the scale settle around you like a soft blanket. Billions of years before you. Millions after. Continents shifting like slow dancers. Oceans advancing and retreating. Species emerging, experimenting, vanishing. Your cities hum tonight, lights glowing against the dark. Data streams invisibly between satellites. Engines burn fuel laid down in carboniferous swamps hundreds of millions of years ago. You are borrowing ancient sunlight and turning it into thought. It's astonishing, really. Whether first or not, you are undeniably rare in this moment. A species aware enough to question its own precedents. The rocks beneath your feet are patient. They will record what you do next, in isotope ratios and sediment layers. They will not judge. They will not intervene. One day, long after your languages have dissolved and your monuments have softened into hills, a thin layer in stone will whisper that something unusual happened here. And somewhere in a distant future, a curious mind may kneel beside that layer, brush away dust, and wonder, were they the first? You let that image fade gently. The cliff face dissolves into starlight. The continents slow. The questions soften. You are here now, breathing this atmosphere, walking this crust, participating in a planetary story billions of years in the making. Whether you are the opening chapter of civilization or simply one chapter among many, the responsibility feels the same: to understand, to question, and to tread lightly on a world that forgets nothing, even as it erases almost everything. The Earth turns quietly beneath you, and deep time waits, patient as ever. You feel your thoughts slowing now, like sediment settling in still water. The vastness that once felt overwhelming begins to feel steady instead, reassuring in its scale. Billions of years have passed. Billions more will come. The planet has endured fire and ice, impact and upheaval, and through it all, life has found a way to continue, to adapt, to begin again. Whether you are the first civilization or simply the latest experiment in intelligence, you are part of that continuity. A brief flare of awareness in an ancient, ongoing process. There is no rush in deep time. No panic. Only cycles. So let the questions rest for now. Let the continents drift without your supervision. Let the moon hang quietly in its orbit. The rocks will keep their records. The atoms will keep their ratios. And you can simply breathe, small, temporary, and wonderfully conscious in the middle of it all.